Okay, hello all again. Welcome everyone. Probably today it'll all be the sessions on demonstration on how certain things are done on Palo Alto. So I plan for 3 to 4 labs, a short lab which probably would last for about 45 to 1 hour. So let's quickly get started. And um, if you people have any questions, you can raise your hand or ping me in chat so that we can clarify them then and there. All right. So just allow me a minute to share my screen. Yesterday we looked at basics of firewall, right? And we spoke about what a switch or a router or a firewall would actually do and what they actually mean in a network. And we briefly spoke about which layer a firewall would fall under. And the features of Palo Alto, we spoke about packet flow in brief. And I showed you how to configure the administrator on Palo Alto firewall, right? So we'll look at how a management IP configuration is done on a CLI or a GUI. So from there we get going with how to take backup of the firewall and how to restore the config if you just have a backup, and if the firewall fails for some reason, you had to reboot and restore the config on the firewall, right? So then we'll be looking at how packet capture is done on a Palo Alto and how to view them. So let's get started. So we'll use the same lab. I'll just quickly open up the firewall GUI. (2716). So first we'll look at how an initial configuration on a firewall is done, and we will move on to looking at how a backup is taken and how to restore the config, right? So first thing, good thing to explain is if you are getting a brand new firewall, all you have is a console access initially. So you straight away won't have a GUI access to it unless and until you're connecting it to a PC. So let's say there is a PC here and you have got your firewall just out of the box. Excuse me for that. So I've got your firewall here, and you'll be connecting your firewall to a console port, and you will be taking a CLI session, SSH session to it, and the default username, as I said, would be admin and admin. So as soon as you log in, so you probably need to configure an IP address for it, or you will be able to use a default IP. The default IP address of the firewall inbuilt onto the box would be 192.168.1.1. Okay, so this will be the management interface IP, unless and until you configure an IP or you get an IP from DHCP. All right. So when in real time, if you connect your firewall to the console port and to the PC, you get access to CLI. So as soon as you configure the management interface and an IP over here, or keep this IP as constant and configure, let's say 192.168.1.2/24, you will be having access to the firewall. You'll be able to log into the firewall as well as when both CLI and GUI. All right. So let's see how do you actually configure the management interface through CLI. So it's pretty simple. So like in Cisco, you had to go to configuration mode from the after you change to the configuration mode, it changes its symbol to asterisk or hash. Once it changes, you are in configuration mode and you will be having a prompt to edit over here. So all the command which involves configuring something starts with set, and you will probably be able to uh, guess through the guess the command of CLI through the GUI here. So you are going to configure management interface. If you're getting familiar with GUI, you're going to configure management interface on device, setup, interfaces, and over here will be the management interface. The usual Ethernet data interfaces will be under network interfaces. So for your management interface, you have to go to device, setup, and interfaces. Under that, you have management interface. You will be able to configure. So the reason why we configure CLI is initially you will have only the CLI access, right? So you can follow the tabs that you are actually clicking over here to actually bring up your CLI command. So you probably would say set device config. The tab always works here as well, like Cisco. System. So system in the sense you're configuring something related to management plane. All right. And then comes IP-address. So you configure an IP address. You have to be having a space. Okay, net mask. Two 255.255.255.0, and you have default gateway. If in case you have a default gateway, let's say you are behind a router or a switch, which is the gateway for your network you're configuring, you probably can give a default gateway. In this case, probably you don't have to. If you don't want a default gateway, if something is directly connected for you to access the firewall initially, so something like this. Let's say you're directly connecting your firewall to your uh, out of band network. So this is a firewall. So let's say you have a switch here, and let's say this is having your gateway. This is acting as your gateway. You have to configure a gateway so that you sitting somewhere out here on some other location connected through VPN to this site where the firewall is shipped, you probably will be able to connect to the gateway first and then to the firewall. So in case where your firewall is in your physical location, you are connected directly to a PC and your firewall is like this, directly connected, you probably don't need a gateway. You configure an IP here and configure a similar IP here, configure the firewall, and then connect it to the network. So depending on whether you need a gateway or not, you configure your gateway or you don't, right? So that's about configuring the interface, and you come out. So now if I hit on commit, the configuration will get committed and I will be assigned with an IP address of 192.168.1.1 here, which I don't want because currently I'm able to access the firewall using DHCP. Currently, as I said, I'm connected directly to the management network. This is the network of my own PC, which I'm working with right now. So since I'm connected directly to the management network, I'll be having access to the management interface through my browser itself. So I'm not going to commit the configuration. Instead, I'll come back to the GUI. I'll show you how to do a revert. So I've done some changes. I've done some changes on device and network, and I'm going to revert that. Only my changes here. Okay. So this is how you configure a management interface, and you commit the config. So to commit the config on your CLI, the command is just commit. Okay. So then we'll see how do we do a backup and restore of a config. So for that, I will first erase some of the config that I have already done on the firewall. So I go to security. I should have a security policy defined here. No. Okay. So let's say I am configuring something here, just to know before I take a backup and after I take a backup and restore the config with one of the backup configuration I've taken actually gets applied. All right. So I'll say it's an internet rule. Okay, I don't have any zones here. Let's say it is any. Destination, let's say it has an object, something like this, and application. I'm just configuring an object right here. So I'm just selecting any zone, just so I will be able to load the config and see if something is getting loaded up when I load the config. So I just created a blank rule. So after this, I will be taking a backup, and I'll show you what taking a backup looks like and what are the difference between candidate config and running config. So post that, we will delete this rule, commit the configuration, and load the configuration file we have saved right now. All right. Are you all able to follow me, or is there anything?
Yes, Ajad, we are following
Okay.
it.
All right. Thank you. So the configuration is getting completed now. So once you receive a message saying the config is complete or committed successfully, yes, you close the tab and you will have this configuration in the running config of the firewall now. So right now I'll go to device. So I wanted to see the difference between my unsaved config or uncommitted config and the configs that are completed. So how do I do that? Let us say I go ahead and do some other config over here. I create some public IP object. So this config is not yet committed. This one is committed, and the rule that I've created is committed. So I'll go to device, config audit, and I go to running config, candidate config, and I say context to be maybe 10 and click on go. I should be able to see what differences I have from running config to that of the candidate config. So candidate config, as I said, 8.8 is something that I created, but I have not committed. So that shows up in candidate config as something added. Green means added, yellow means modified, and red means deleted. All right. So rest other configs are all committed and it's grayed out. Okay. So I have created a 10.0.0.0.24 that is showing up, and There is a rule that I've created which is already committed, so it's not showing up. It is actually hidden behind the running config. So if I've made any changes on the rule, it might show up. So basically, the configs that are not committed and it is still pending to be committed shows up in this candidate config that's called as candidate config. Running config is something that we have already saved and it is currently running in the Palo Alto firewall. Okay. So I'll also revert this change I have done. So that 8.8 will be gone now. It is gone. So this is how you differentiate what a candidate config is and a running config is. Running config is the configs that are committed. Candidate config is the configs that are pending to be committed. That's just a raw change done on the firewall. Okay. And we also have to talk about how do you back up a config, reboot a firewall from the GUI or CLI, and so on and so forth. So backing up a config, it's just you have to go to device setup, operations. Here you have a lot of options. So revert to last saved config. This is something which you could do if you wanted to revert to last committed config. Okay. Save. This is to save the configuration on the firewall with a name. Let's say I'm running with this configuration currently, and I have an object here, private, and I have a policy defined here, internet. If I have to just take a backup of it and save it onto the firewall, I go and say I give it a name, and save this. So this, what you did right now, saves this config only to the firewall. So if you just log into the firewall, you will be able to see this configuration and you will be able to download them to your local machine where you're accessing the firewall from. So I'm accessing the firewall from this PC. And if I have to save the configuration that is available on the firewall, which is already saved on the firewall, let's say if you do some more changes, the current version of the firewall I have saved will not be available. So for that purpose, you save this configuration on the firewall and you do keep doing more changes. If you wanted to revert back to this version, you can very well do that. Okay. So now you are going to export that config, meaning you're going to save that config to your PC from the firewall. So I've saved it as nj blank config. I take this, I click OK. So it will be downloaded back here onto your PC. So this is how you save the config to the firewall and save the config to your local machine, download the config to your local machine. So if let's say you wanted to load the config to the firewall, for that, let's say I'll delete this and commit the configuration. Okay, so this can't be deleted. Okay, let me show you something more. So it says it can't be deleted because I have used this object in a rule that we have defined in the policies, right? So we have defined some rule in the policy that is a blank rule that doesn't make any sense, but then this object can't be deleted because this object is referenced somewhere else. So likewise, if you create something and you reference it somewhere, unless and until that reference is removed, you will not be able to delete the actual thing that you have created, actual parameter that you have created. Okay. So instead, I will go ahead and delete the rule. So this rule is not referenced anywhere. The object in the rule is referenced to this rule. So I can delete this rule logically, right? So I'm deleting this rule. I'm committing the configuration. Just so if I reload back the configuration I have taken, I should get back this rule, right? Let's wait for the config to get pushed or committed. Okay, config is committed now, and you don't see the rule now. And when I go to device setup operations, I already have a configuration saved on the firewall as well as to our local PC. So if I say load named configuration snapshot, it'll give me an option to choose from the saved configuration, which is this. I say okay. Configuration is being loaded. Please check the task manager for its status. So where do you go for the task manager? We close this. So you see here something called task here. So you go here, you see something called load being executed. So load is complete. How do you view this in the CLI? So you go to the firewall. So you say show jobs all. You see something called load is getting got executed, and then status is finished and result is okay. So if it has failed, it will say result failed, and everything will have an ID for it as well. So all these things behind this load queue, behind this load in the queue will be the committed configuration that we did. So we did a review change, you remember? So this is an auto commit. So this is for yesterday if you remember, yesterday we have logged into the firewall for the first time with the username admin and password admin, and we changed the username and password as per the suggestion, and it will be auto committed. Okay. So when the time when it is committed, everything will be shown here. So if you wanted to kill a job which is taking too long, sometimes there will be a bug in the firewall where you're going to commit a config. On GUI, it will show 0% or get stuck in 10%. You quickly come here, you will have to check what is the job, and you probably have to kill that job and initiate the commit again. Okay. So other options in here, you can reboot the device, shut down the device. So if there is a maintenance going on at your site, you probably have to shut down all the network devices before the power maintenance starts, and then if when it comes back up, your job is just to test. So that's about why you shut down a device. And the configuration is now loaded, and you see there is a commit pending. So after the configuration is loaded, you probably need to have a commit done. So let's finish this commit and then go and see if that rule is available. Even now the rule should be available as a part of candidate configuration. You see the rule has been deleted and committed, but now it is available as a part of candidate. Before the commit succeeds, let's try to check that in the config audit. Let's see if we can catch that. Yes, under the candidate config, it shows now as the rule is shown in the candidate config now, which means the config is not yet committed. So I think maybe it's committed now. When I see this now, I will be seeing it blank because there is no candidate config available now. The versions are identical. There is no changes that are pending. Both the versions running config and candidate are identical. I've committed all the configs that I've made, so it is identical, so it won't show anything. Okay. Are we good with this?
Yes, Azad.
Okay, thank you. So next thing we have is we did the initial configuration, we did backup and restore and config audit. We have done this, and GUI and CLI walkthrough, and probably I said I'll add one more. Internet access. So how do you how do you get a basic internet access from through the firewall for a user, which probably we'll look at right now. So let me delete this rule. This is a test rule that we created and the object as well. So I also have a PC here. If I try to open that, just give me a second to log in, guys. So the PC is already pre-configured with the IP address so that it connects to internet when we have all the configs properly configured on the firewall. Okay. So things are very basic. So if I see right now, the internet adapter says internet is not connected. And if I go to CMD, and give IP config to check what the IP is, it's 10.1.1.1, and the gateway I've given is 10.1.1.10, assuming that I have to configure this on the firewall. Okay. So let me minimize this, or let me leave it as it is. I'll go to the firewall. So what I basically need to do, if I have to get an internet access, let's try to write down the steps. So in a general networking terms, if your private space has to reach internet, it should have connectivity to its gateway. Gateway should be reachable, which will happen when we configure an interface with the IP address we have provided the PC as its gateway. So gateway should be reachable, and on the device which is facing the internet, we should probably do a NAT. And third thing, you should have internet connectivity. This is general internet terms. In general internet terms, you need to have these things set when PC needs to access internet, right? Since we are dealing with firewalls here, we need to have one more thing that we need to do, where we need to have a security policy that supports the traffic. So we need to know which zone the traffic comes in from, which zone it goes out, and what IPs are involved, source and destination, and what protocols or applications, and then allow them accordingly. There should be a security policy that supports the traffic that you're initiating. Okay. So let's place a tick mark on one by one by configuring them. So let us go to network. First, we'll configure zones. So zone is something that represents a specific area of a network. So let's say users might be differentiated based on their departments, but everyone are corporate, and everyone are will be coming in through a specific zone called corporate. Let's say people using Wi-Fi or people using LAN, they all come in using a single zone. So let's say there is a lab network that is specifically there in the office. You might have a different zone called lab, but unless and until you have everyone in the same zone, everyone coming in to reach internet will go out from one zone to address zone, right? So zone is something that you should always have on any interface that you are ingressing or egressing out to. So I'll just configure two zones right here. So for that, I go to network zones. I go and add up two zones. So which is the zone name can be anything. It is just for you to understand and make sure you choose the proper zone for proper use cases. So here I say trust, and the interface type that I'm going to assign this zone to, or the zone type, will be layer 3, because the interface of the firewall will be having an IP address, and this is the zone that is supposed to be attached to the interface, right? So I'll click OK. I'm not adding any interfaces here. So this can be done in two ways. So you create a zone, add an interface here that applies to the interface. Under interface, you will have an option called zone. Over there, it will be applied automatically. Or else you just create a zone here, go to the interface and add the zone there. This will be automatically populated. So either ways it works. Okay. So I've created a zone called trust layer 3, and I will create another zone on trust. This is also supposed to be layer 3, and I click OK. So now the zones are created. We go to interfaces. So let's see which interface connects where on our setup. 1x2 goes to the PC and 1x1 goes to internet, right? So we go to 1x1 and we say it's a layer 3. And as soon as you go and choose layer 3 here, it brings up a lot of options. Okay. So virtual router. This, if you understand general networking in Cisco terms, virtual router is something which is equivalent to VRFs. So if you know the concept of VRF, it is having a single physical router dividing its routing table into multiple routing tables, depending on how many VRFs you have. So you say VRF1, you say VRF2. So logically, this interfaces which are in VRF1 will run a separate routing table, and interfaces which are in VRF2 will run a separate routing table here. So similarly, you have a concept of VR. So since you won't create any VRFs in a router, doesn't mean that the router doesn't have a VRF at all. So by default, the router runs with default VRF, right? So similarly, you choose the already available virtual router here called default, and you can have all of them in the single virtual router, or you wanted to have separate zones in separate interfaces in separate virtual routers like VRF does. You can do that as well. So for now, I'm keeping everything to default. And here is where you choose the security zone. So I go with untrust here because 1x1 is untrust, and I give an IP address. So in this case, if you see my setup, I've connected this to my management cloud directly. So this one will act as a DHCP server for me. So I can choose this as DHCP client. Okay. And I click on OK. I go to 1x2. Similarly, I choose layer 3, virtual router default, zone trust, and IP address here will be 10.1.1.10 as per the PC's gateway /24, and I click OK. So far so good. So we will just go for policies now. Click on add. Internet access. So this is just for description. You can just write down for your descriptive purpose. Maybe in real time, you probably will be adding up your ticket number that you're working on or something like that. So here from trust, I'm not choosing any IP address. If you want to, you can create an object of 10.1.1.0/24 for all the networks from this subnet, and then add them here. For now, I'm keeping it as any. Destination will be untrust, and since it's going to be internet, I will be leaving it as any. Application, let's say SSL. Application default. So here I've chosen SSL as an application, or I will also choose web browsing, HTTP. So HTTP and HTTPS. So only for browsing, I'm allowing this traffic. And if I say application default, the default ports that these services work on will be allowed here. If I have to choose between what services that I should allow, that is a port number, I can choose between them. But then uh, if I just keep application default, SSL works on 443 and web browsing by default works on 80. So these two will be allowed as a part of application default keyword that we have provided here. So action will be allowed. Click on OK. So this is done. Let's commit the configuration. Let's wait for this to get committed.
Hi, Azad. One small question. Hello.
Yes, sorry, I was on mute. Yeah, tell me.
Okay. When you configure this interfaces, you made them in as a part of zones,
Yes.
and then you showed us like it can be part of the VRFs. Okay, so when you assign this, does that zone also become the part of or that VRF, or it's
Uh,
always binded?
no, it is not necessarily that, because you are binding this zone to an interface, and on the interface you are choosing whether you are going to work towards default virtual router, that is VRF, or any other VR that you create under virtual routers here that you see here. So zones doesn't have any connection with the VRF. If zone is binded to an interface, yes, the interface has something to do with the VRF, not the zone. Because if you think of routing, how routing happens, routing's major part is to find out what is the next hop or next interface it has to go out to, right? So in that case, interface and VRF bind together and work together, not the zone. Zone comes into picture here because an interface to work, if an interface has to work properly, it needs a zone. But let's say interfaces and zones are directly interacting, and interfaces and VRFs are directly interacting, not the zones and VRFs. So if I have to explain it in another way, let me take my pen. So this is the firewall. So you come in with a zone called trust, you go out with untrust, and you don't have any VRF now, you are running on default VRF. So you come in, you go out. So when you come in, you see, guys, give me a second, I'm just getting a call. I guess just give me 1 second, please. I'll just get back my screen and share them again. Okay, sorry about that. So as I was talking about the zones and VRFs. So you say VRF is a part of an interface, not a part of a zone. Why I say that is because when you have a firewall, you have a routing defined on the firewall, and that belongs to, let's say, a default VRF. Excuse me. This is trust zone, and this is untrust. And this one, let's say it belongs to default VRF. And this VRF is only responsible to know what the traffic is, what the destination IP is. And for this destination IP, if it has any um, routing defined in it, or there is a default route, and what is the next hop IP address, or if I have to go for the next hop IP address, which interface I have to go out to. So it all talks about interfaces. So zone is just to make sure your traffic is a part of specific boundary, and whether the traffic is binded to an interface or not. So the zone goes hand in hand with interfaces. Interface goes hand in hand with zones, and interface goes hand in hand with virtual router or VRF. In this case, why? Because it has to find out what the next hop IP address is about, or how to route the traffic. So you always can make sure interface and VRFs are probably working together, not zones and VRFs. They both are not directly interconnected, but through interfaces, yes. Did that answer your question, or do you need some
So
more?
first I can tell that zones are for security purpose and
Yeah, that's
VRF
right.
that's with routing.
Yeah, VRF comes with routing. So VRF is just to make sure. Let's say you have two departments. You have a lab network. You have your corporate network. So lab network, they will test so many things with unauthorized devices. That's for testing purpose. So these things should come with this zone. And when you write a security policy, you always have your security policy having zone as an integral part, right?
Basically, okay, I got it. Like example now, oh, when you created this one rule, you created untrust, trust, and then you set an interface. Since it was default, so it's a completely setup of one VRF, which is default. Okay, tomorrow I go ahead and create a VRF X, Y, Z.
Yeah.
Okay, so do I need to create additional zone for that,
No.
or default zone will be used? Can be used.
So where are you interconnecting VRF and zones here in this case? Tell me. So when you create a zone, you're not defining any VRF here. You're actually defining an interface
Hmm.
which where the zone belongs to. And when you create an interface, what you do, you go and define a zone to it, and you go and define a VRF to it. So why you are defining a virtual router is because that's the actual job of virtual router in any network device you might think of. So if you take any layer 3 network device, it has a routing processor. So this routing processor, what it does, it takes the incoming packet, it puts into the routing table and processes the routing table and checks. So I have to go to 8.8.8.8. So do I have a specific network? First thing it will check which VRF it is a part of. So it's a part of VRF A. So it only goes and checks the VRF A. VRF A has what? It has the routing entries. So it checks whether there is a direct static route available, or specific route available for this network. If it doesn't find one, it will see whether there is a default route available. So if it's a default route available, it will process that default route and see what is the next hop IP address. So how do you write a default route in a router? You write IP route 0.0.0.0 0.0.0.0, and you write the next hop IP address or interface, right? So it has to find this interface, and it has to pass the traffic through this. So while it does that, it will also check incoming and outgoing zone. For incoming and outgoing traffic, is there a rule available on the security policy? So zone doesn't come into picture when you actually think of whether or not the routing is properly configured or not. So zone comes into picture when the security policy is read. So only after defining the routing, only after defining, okay, this is the source, this is the destination, and I have to go through this interface to reach this destination, this next hop. After it finds the routing, it checks the security policy. So that's what we saw yesterday as well. And when the slow path started, first it checks the forward lookup, routing lookup zone. It finds the source zone, it finds the destination zone, and then checks the security policy. So how does it do a lookup of routing? It does it through VR, virtual router. So VR is just to see what is the next interface it has to go out to for a specific traffic. So once the next hop interface or IP address is found, it goes on to check the security policy to know whether the source zone or destination zone, IP address, protocol, application, everything is allowed, and then so as to allow the traffic through the firewall. Am I clear?
Yeah, clear.
Okay. Okay. So we have now configured interfaces done, and we have configured a policy. So we have something left over, which is routing. So routing in the sense the PC has a gateway IP address and they are directly connected. There is no VLANs involved. So it will be able to reach the gateway now. So let us confirm that. So if I try to ping this, I'm not able to. So the reason would be this, that I said that by default, when you try to connect to management interface, as soon as you configure a proper network, that is the same subnet IP, you will be able to take SSH or SSL. How does that happen? By default, management interface will be having SSH and SSL built-in allowed on the box itself. So for any data interfaces, you need to allow them through a specific profile. So how do you do that? So you have something under network, you have something called interface management here. So here you have I've already created one. So when you have to create, you just go give it a name, choose the services you wanted to allow, and if you wanted to have a specific IPs allowed, you can do that as well. So I've created SSH, HTTPS, and maybe I'll allow ping as well. Okay. I go here to interfaces. I'll have to map this to the interface I need to have access to. So I go to 1 by 2. So I tried to ping 10.1.1.10. I was not able to. So when I go here, I give advanced. Over here, I allow this profile and click OK. So it is just warning us by telling we are exposing this interface. That's okay. So you always give a comment. Right now, just I'm giving a commit. So once this is completed, I should be able to achieve a ping to this gateway IP address. So let's do a continuous ping. So as soon as this is completed, I should be able to reach the gateway. So next thing to do is configure routing and configure a NAT policy. So now I'm able to ping this. So to take care of routing, so since I'm able to reach the firewall's inside interface, all I need is I need to have a routing to reach internet. So which you will do here under default route VRF or virtual router. You go to static routes, you add a static route, give it a name. Destination will be 000/0. Interface will be 1 by 1. Desktop IP address you can give none because it is a DHCP. So before doing all this, if I go to interface and see the outside interface here and go to IPv4 and I've given DHCP. If it is a static IP, the seed is different. We have to come to virtual router and configure a default route. But if it's a DHCP client, it has an option that says automatically create a default route pointing to the default gateway provided by the server. So this is what we were supposed to do, but it's already done as per this message and it's checked in here. So we just click OK. We just commit the configuration. So one more thing that I find as a glitch in Palo Alto even till now is, let's say you open something. So this config here available right now is let's say already been committed. But then if I just open this and I don't do any changes, I just click OK. It will take it as I have done some changes. And I will be able to see that I'm able to commit something here. So even if you don't do any change on something, but if you click on OK instead of cancel, so it will take it as you have done some change and it'll show it in the commit pending changes here. So that's something that you don't have to get confused about. There is always a way to check what's been done by doing a preview change and clicking on OK. It will show you the changes that you have done.
So,
Okay,
Azad,
so
this is with the specific version, or like it's across all versions?
yeah, it's across all over the. I worked with Palo Alto firewalls. I mean, the current version running is, I guess it's 10.2, 10.2.x. Even there, you have this issue available. You can't say it is an issue. Maybe it is something that it takes when you just click on OK instead of cancel. It always takes that you have done some changes and shows up in the commit section here.
But when we'll check in configuration
Preview
audit,
changes, preview changes, you won't see anything, and in config audit, it won't show up anything because the versions will be identical, the candidate and running config. Yeah. Okay. So the routing is done. So only thing we are left with is to configure a NAT, and then I will be able to ping internet now. So right till now, the internet is not working. I'll just give a continuous ping for 8.8 and let us configure a NAT policy.
Do we have a policy to allow the ping?
Yeah, we did create a policy, right? We created a policy from
ping
trust
is not
to
allowed.
probably yes, we can allow ping also. Yeah, that's a good catch. I just was planning to browse something. Let us allow ping. Sorry. We'll commit it all together. So we'll go to NAT policy. Click on add. So right now we are going to do a source NAT, right? The source of the traffic will be NATed. So we say a trust and destination zone will be untrust. And we don't have to worry about the interfaces. If you have to, you can just choose one by one. But for now, we'll leave it as any service, any. Addresses, let's keep it as default. Translation type. So here, if you're not doing a destination translation, let it stay none. Source will be dynamic IP and port. And translated address will be interface address. And it will be one by one outside. And IP address, since it's DHCP, we'll keep it as none. Okay. Click on OK. So now we have a NAT policy setup. So this will work well when users have to reach internet. Okay. We click on commit. So there is one more thing that you could think of. As I said, preview changes. You could always see what changes you have done on the firewall. Why is it not showing up? Okay, for some reason I'm not able to run the preview changes. I can also do, before you do a commit, you can validate the commit. So let's say you have done some mistake. Let's say you're configuring an IP address instead of saying 10.1.1.0, you say 10.1.0/24, or maybe space/24, something like this you have done, and it might fail. And if it is failing, maybe you work somewhere and then you don't have to have a have your name saying that your configuration, what you have done, is failed, and it's all recorded in the logs, right? So you probably can validate the commit. So by doing a validate, you will come to know whether the configuration is valid, what configuration you have done, on which section you have done, and if it is valid or not. So this will give you an idea whether the config you have done is proper, and then you can go ahead and do a commit now. So NAT policy is done, and we have added a ping to the security policy. So as soon as this gets completed, you should be able to see this ping working and internet coming up. You see, I'm able to reach internet, and you have got the access now. So it's just done in 2 to 3 steps, where you just have to take care of security policy, NAT policy, and proper interface configuration and routing, right? Then I think we are just left with and maybe we will also see how a session would actually look like. I will also initiate some more ping here, and we'll go to the firewall again. Under session browser. So as you all know, ICMP, the timeout is 1 second, so you won't be able to see ICMP logs here unless and until it is running continuously. So if you have to track ICMP logs, you have to give a continuous ping here. So if you just open one of them, I'm just coming from 10.1.1, 8.8 towards 8.8. So in here, you will be able to see forward and reverse traffic, and the flow should say active for us to understand that the flow is actually working. And if it says discard or something else, you have an issue and you have to troubleshoot. And it also says which rule it hits, what application it is, what is the IP address, actual source and IP, destination IP, and what is the ingress and egress interface, how many bytes of data, what VSys we are in. And if you have to clear that session, let's say the session is stuck, you have to clear and reinitiate again, you could always do that here. And on CLI as well. So when you open up the session, you see all basic details in here. Flow 1 is forward traffic, client to server. Flow 2 is server to client. And when it's client to server, it is 10.1.1.1 towards 8.8. And type is flow, and state is initialization. So since it's not a TCP, it will not have flow as active. If it's a TCP traffic, it will show the flow as active. And if you see here, the reverse traffic from 8.8 is coming towards 172.16.27.19. Why this IP? That should be the NATed IP that you will be seeing here on the DHCP client. If you click on this, So you see 27.19 here. So this is the IP we routed the traffic to, right? So that's about the session logs. You now see the session is active. It should show session is active only for a TCP session, but then, okay. So that's about it. You could probably try this out when you get the lab access. We'll also be extensively seeing how it is done and what other features we have in the future sessions. We'll wrap the session up by looking at how do you do a packet capture. So doing a packet capture on a Cisco router or a switch might seem pretty confusing because you have to do so many things there. Over here, it's all GUI, so it will be pretty interesting and easy for you to understand. So you just have to set up a filter for your traffic. So you'll be at a time troubleshooting one specific traffic, right? So you can just set up a filter. Let's say it's from 10.1.1.1 towards 8.8. I'm not caring about source or destination port or protocol. So I'll give a reverse flow as well, starting from 8 towards 1. Okay, so this is my filter. And coming to stages, so you have 4 stages here. One is drop, receive, transmit, and firewall. So receive, when the traffic comes into the firewall. Transmit is something the traffic goes out. Firewall is the traffic that is to the firewall, destined to the firewall. Drop is something that the firewall receives it but drops it for some reason. So we will set up everything, and probably what we have to expect right now is, since the internet connection is working, we expect there should be no drop file generated here. So for all the stages we set up here, there will be a separate file generated, PCAP file. So we should not see a drop file being generated because there is no traffic being dropped for this specific filters we have set, right? So we'll say receive first. So we'll give it a name, RX. And we'll add one more, transmit. And we say firewall. We say drop. Okay, so all 4 files or stages are created. So now it's time to switch on the filter so that the filter will get activated, and switch on the capture. So if you refresh, the real-time logs will be getting generated and saved onto this file automatically, and the traffic will be refreshed. So you see, this is the size of the data and when it is generated. So there are some drops as well. We'll see why. So we'll switch off this, and just by clicking over here, we'll be able to download the file. First, we'll see what the drop is about. So maybe it's for DNS. There is some delay in DNS, so it is dropping DNS. So we didn't filter any specific protocol, so it is dropping that. Otherwise, if you just look at receiving side of it,
I think again we didn't allow the DNS in the firewall tool, right?
yeah, we did, yes. So you see the traffic, ICMP and DNS coming in and going out for 8.8. It is trying to resolve the DNS, but it is not able to. So this is how basically you capture the packet, and something on Wireshark to know about. So you have captured the traffic based on the receive, transmit, firewall, and drop. So what if you wanted to club everything together? So for that, you open up any one flow and you say merge, and you can merge down receive, and the traffic will be merged. So you see now 10.1, 10.1 to 8.8 ICMP, and you see the reverse traffic as well. Echo request and echo response. So these two probably should be sufficient for you. If you wanted to know the drop traffic as well, you save this file and then merge another file called DR. That is, we saved it as DR here, and then you can view that as well on the same file. Okay. I hope I'm clear. So do you have any further questions before we wind off? As I said, you could contact the number or email address that you see on the chat for any further queries regarding admission or pricing. You could contact them, then they'll be able to help you with the best. So you have any
So,
further questions for me?
yeah, actually, you have like this packet capture were done in the firewall, no? So
Yeah, it is
all
done on
the
the
files
firewall.
were saved in the firewall. So if I want to keep someone else, like some different servers, I want to specify. So is it possible, like I want to capture all the traffic and flow in a particular server?
So meaning you are telling you wanted to capture the Wireshark and save it on somewhere else, save it somewhere
Yeah,
else.
yeah.
So that's what we are doing, right? So if we are capturing it here
Mm-hmm.
and downloading it to the file, downloading the file to these three
No,
stages.
but if I want to keep this as a continuous, I want to get each and every logs regarding the packet capture as a as a filter one, and I want to make like some different servers, and I'll put that there. So is it possible that I can get the whole capture of that particular filter packet on that different
I
server?
I don't have a direct answer for that because Palo Alto doesn't support anything like that directly
Mm,
with its features. But then what you could do is you could set up a log forwarding to a external log server. Let's
yeah.
say you have a device tab here and you have syslog here.
Mm-hmm.
So over here you could set up a log forwarding and point it to the syslog server you want to, and then the logs can be forwarded, which is for sure I know can be done. But regarding the packet capture, so only when you capture the packet, so you can't really capture the packet of a firewall 24/7, because as soon as you switch on the packet capture here, it gives
Yeah.
you a warning message which I didn't talk about. I switch on capture now again. It gives you a warning message saying for troubleshooting only, this feature can affect the system performance or degrade the
Okay.
performance of
Okay.
the firewall. So you can't 24/7 do this and keep capturing it onto server. So instead, what you could do is you could do a device capture. Sorry, the log capture on from the firewall to any other syslog server, the traffic log or threat log. You go to device, go to syslog, you add a server, name to it, and you add a server, and you bind this syslog server to the profile that you are going to create, and in that profile you will define what logs that you want. So whether you want to capture the traffic log alone or threat log or URL filtering, so you can just send all these logs on to the syslog server, right? That
Yeah.
can be
Got
done, but this one probably not something that we will be allowed to do in our network, because it will choke our utilization of the firewall, and we might face some disruption in the network.
And how do we manages multiple firewalls?
Yeah, I didn't talk about Panorama here, which will be done during our course as well. So managing multiple firewalls, I'll just tell you in short. Let's say you have something called a management server here. Let's say you have some 4 to 5 locations, or let's say more than 5. So these many firewalls are there. And if let's say you wanted to manage all of them under a single management console, you go ahead and join all these firewalls. There is a specific method that you do this to join the firewall to this management server. So after you do this, all the configuration management can be done. All the logs can be viewed through this management server. So this is called Panorama. So with this Panorama, you go on to this on one single device, log in using this its IP address or domain name, like you do for the firewall. You will be able to control all the configuration of these firewalls that are available in your enterprise network through one single console. And you can view the logs of everything through one single console. So let's say you have a user coming in and saying, I can't access the server of this IP address from this IP address. So let's say you don't know where this is located and where this is located. You don't know which firewall to log in and check. If you don't have a management server like this, it will be a nightmare for you to first figure out which site this guy is actually trying to access from and where is he going to. Whereas if you have a management server and you're sure that all the firewalls in the in the enterprise network are supposed to be managed from this management server, you go here. This also will have a similar GUI with a little difference. You just go to monitor tab, you go to traffic log, you just type in the source and destination IP address here, filter it. It will itself show you which rule it hits, and finally it will show you which firewall the traffic is going to hit. So with that, you will be able to identify which location the user is actually trying to access and where is he going to. So there are so many things that will be simplified if you are having a management server like Panorama, instead of having a standalone firewall and managing them together. So there is also an option where you have 10 firewalls and you have a centralized DNS setup or centralized DHCP. So all the 10 locations comes to this DNS server and DHCP server for these two services. So all you will do is from your own private network, you will say to reach this DNS or DHCP server for this DNS and DHCP application, allow the traffic. So this is one single rule that you will be applying to all 10 firewalls, right? So if you have a management server that manages all these 10 firewalls, you create a group that contains all these 10 firewalls and configure this this rule that I spoke about for this DNS and DHCP traffic and push it to all 10 firewalls together instead of configuring it to all 10 firewalls separately by logging into them separately. So these like this, there are so many advantages that you could think of when it comes to managing a firewall or group of firewalls under a single management server. Clear?
May I know how to take a TCP dump via CLI? It is possible.
Yeah, it is possible, but it will not be a part of the demo session. Yeah, but surely we'll be having a session on it for our class, and I will be scheduling a session for it. So it's just about 3 to 4 steps that you have to do. So first thing is in GUI itself, you set up a filter like this under packet capture. You set up a filter. After you set up a filter, you have to set the debug to which level of debug you want to do it. So let's say there is a command debug. So if it's for data plane, you say data plane. If it's for management plane, you say management plane. Debug data plane packet diagnostic. I think it's set log feature flow. So you have basic, advanced. So advanced probably you won't use as an administrator. It is a tag that you who will be able to understand that. So maybe you could use flow basic. So once you do this, you will be setting what type of flow you are, what type of debug you are going to do. Then you have to switch on the debug. So the same command, debug data plane packet diagnostic flow. Sorry, set log on. So after you do this, the packet will start capturing. And then if you want to switch it off, the same command, you go off. So after that, the file will be saved to one specific extension .log. So you can go ahead and view that or download that, whatever you wanted to. So we'll be demonstrating this extensively. But for now, this is how you do it. So you first set up what flow, what debug you wanted to do, and then switch on the debug and wait for some time till the traffic is initiated, switch it off, and then view that under. So there is also a command to view that. It's less mplog pan and the file name. So yeah, we'll look at this, but unfortunately not today because we are already time, and we'll have to open the session for questions. So yeah, I hope you understand. So any further questions, guys?
Ajad, Suresh here. Can you please
Yes.
show the how we can configure a user ID?
So configuring a user ID is not something that you do on the firewall itself. So if you're planning to have a AD server, so you need to have that database being copied in here. So in short, if I have to say, so the user ID configuration is basically done over here. So where over here you configure a profile first. You configure an LDAP profile. Over here in the LDAP profile, you say what is the server that you're going to configure and what are the domain name lists. And after you do this, you go to user identification. You say under user mapping, if you wanted to monitor the server status, you configure them here. And this protocol WMI is a protocol that it uses for, let's say, a Windows Active Directory, Microsoft Active Directory uses this protocol, and this should be enabled over there, and including and excluding addresses. User ID agents, if you wanted to set up the user ID agents, like if the traffic is not directly going onto the user ID, that is the Microsoft Active Directory, and if you're setting up a PC in between that logs everything and then collects everything and then gives it to you, you set up a user ID agent here. It's just a PC that collects the log. Okay. Over here, if you have a terminal server, let's say it's similar to the user ID agent. If you have a terminal server, you configure that here. Group mapping setting. Over here, what the user domain is, server profile that you have configured so far, the LDAP profile, you define it here. And other configs are just optional. If you wanted to have a captive portal, you enable them here and give a timer timeout. And rest other configs, you do it on Microsoft Active Directory. So I'll also have a lab on AD and user ID mapping when we have the session started. So first we'll look at the basics on how a policy is dealt with, how to configure an object, how to view logs. So the basic configs like how to do a routing, dynamic routing like EHRP, OSPF, then we'll look at this one. So right now it's not possible for you to configure and show, but this is how you do it. And you have certain configuration that you have to do on your Active Directory as well. So which we will be discussing in the session.
Thanks, Azad. Thanks. Nice explanation.
Yeah, what is app ID? Will you elaborate?
Yes.
So
What is
Azad,
app ID in Palo Alto?
Yeah, app ID, we discussed it yesterday, right? So if you can watch yesterday's recording session, you will understand we spoke about all the features of Palo Alto. So app ID is again the feature of Palo Alto used to identify what exact application the user tries to access. So initially, let's say I'm using HTTPS, which means it will identify it as SSL traffic. But inside that, if I'm going on to access an application, which is a well-known application like Facebook or Yahoo or something like that, it will probably identify what exact application and inside that what exact application, like if it's a chat application or if it's a video. And again on Yahoo or any other website, what exactly we are accessing, and if that application can be segregated, it will do so by using its own app ID signatures. So the Palo Alto has its own signatures built in within it to identify the well-known applications. So if I have to show you in the GUI, we go to objects, application. Over here, so it categorizes the application based on its category, where it's business or media. If I say gaming, if I say browser based, so it categorizes the application based on. So you see there is a betting app here, Bet365. This is a gaming application where you go on to place bets on international games that are happening. So this is categorized as media, gaming, and browser based, and the risk value is this. So based on the risk value, you allow or deny the application on your security policy here. So how it does that? It does so by initially checking what protocol you're accessing them from, and then checking its signature database to know what is the signature and what category it has to put them into, and then categorizes them as critical, risk 3, 2, 1 or 4. Sorry, 4, 3, 2 or 1. So it is a way of identifying what exact application you actually are using as a user, right? Anything else?
yeah,
For
Azad.
yesterday's recording demo, where it is available?
I think while logging in to the Zoom meeting, you might have provided your email address, right?
Yeah, correct.
You should have got it over there, or you can go and check out our YouTube page.
Okay.
Or in LinkedIn as well, you must have this video available. So in LinkedIn, we have a page for us called NetworkJourney, and as well in YouTube. So maybe. So this is the page. Okay. So this is the session that we had yesterday. So the session 1 or 2. So you will also see the session that's done for today, probably within today evening, end of the day. So you can go and check out in YouTube as well as LinkedIn, right?
Thank you.
Yeah.
Azad, so my question is like, if I see some packets being dropped by the firewall, even though I have policies that is allowing that traffic, so what are our options do we have to figure out like why this packet is being dropped?
So you might have a rule, but you have to check whether the rule is actually in line with the actual traffic you're accessing. So for that, what you could do is you could go to monitor, go to session browser that we saw already. Open this up. Just give me a second. So open this up and maybe take a notepad and write down what actually you are doing and what is showing up here. So maybe you might have missed something, or you can't really say at this point how do you troubleshoot, because if you see the traffic log, there are different messages that it gives for session end reason or for application. So in the traffic log, when you have a licensed Palo Alto firewall, under the traffic log, you will have a detailed log viewer under which you will see whether the traffic ingress and egress is actually happening or not. So over here, if you see, you will not be able to see that in the session browser. Session browser will only say whether the session is proper. Under traffic log, you will not be able to see anything here because this is not a licensed firewall. So under detailed viewer, you will be able to see something called bytes in, bytes out. So this will say if bytes in is having some number, say 12486, bytes out is 0, which means bytes out should have some value. So let's say this is 0. So when traffic is going out, it is having some data. When it's coming in, there is no data, which means on the return traffic, there is some problem. And you might have to check from the destination server you're accessing, you have to check the routing. Security policy is already allowed, because if you see the policy is allowed, you will obviously know that the return traffic is also allowed because it is a stateful firewall. So you might have to check the routing, or you might have to check whether the application is actually responding, the server is actually responding to you. So, or you can do a packet capture and analyze the Wireshark traffic. So it's about how the issue is and what actually you have configured and what is actually happening. So you can't straight away say that you do this and then it will work, right?
So what if I do see the traffic, incoming traffics, there is some incoming packet as well. So in case, do we have any debugs like 40 gate we have, so we can actually look out what's happening at the firewall?
You mean for incoming traffic?
Yeah, like no, I am telling like even I am seeing incoming traffic also, it's like that. As you mentioned, no, it's if we see 0, but in case if we saw it, some packets are there, then what, like server is responding, but like I do see some packets was dropped by firewall.
So you might have to see the packet capture here as I showed you. So we'll have to set up a stage like this, take out the files, bind them together and see why it is dropped. So there may be so many reasons where the queue is full. So you have an incoming and outgoing queue. The queue might be full and there might be retransmission happening, so that because of that you might have delay. So because of the delay, it might probably drop the traffic due to timeout. So many things can be the reason. So you can't generally say it's a single problem, as I said already. So you have to be on real time to identify maybe what is happening. So when you're working on a lab, preparing for an exam, you can only troubleshoot to a certain extent, to a scenario where something that you can troubleshoot, which is absolutely certain. So if it is only real time, you will be able to know what actually is something is happening. So if let's say I'm demonstrating something, I can only show you whether SSH is working. Maybe I can show you a certain scenario where if this is not configured properly, this won't work, and if this is configured properly, it will work. So in terms of delay or in terms of bandwidth problems, it is impossible to demonstrate something for you people in a class. So it should always be dealt with in real time. Because I can't introduce a delay and say this is experiencing a delay, so we are losing some packets here or something like that. So probably if you come across this in real time, you might have to dig in by taking a packet capture and then see why the return traffic is getting delayed or getting dropped. It might be due to retransmission. The queue might be full, as I said, the scaling window might be full, and the traffic that is actually being sent is more than what the interface would receive. You might have to adjust the MTU. So many might come into play in this case in terms of performance issues, right?
Yeah, right.
Okay. If you don't have any further questions, we'll wind up, and then I'll expect you all in the
Hi,
next session.
Azad.
Yes.
Can I get the today's session on YouTube? It will be available, or how is it? Today's or yesterday's session?
Yeah, I already showed you in YouTube what is our page and where you can find them. I just showed you a couple of minutes back.
Okay, fine. So it will be available on YouTube.
Yes, it will be. Yes.
Okay, fine. Thank you.
Yeah, thank you. All right, thanks a lot, guys. Thanks for the time. Probably I'll expect you all.
Azad, just small question. The
Yes.
next section will be like for 1.5 hours or what?
It will be depending on how the management plans. So I'm not sure of how the plan is. Whether it will be most probably 1.5 to 2 hours, because since we are having only weekend sessions, we can't have a 1 hour session, because it will extend like about 2 months in total. So we should probably have a 2 hour session, most probably, if not 1.5. We'll be intimating you about it beforehand. Yes.
And Azad, where we'll get these notifications about the upcoming trainings?
You can contact our backend team. You are provided with a contact number and WhatsApp or an email address, right? So you can contact them through any of them.
Okay.
All right. Thank you all. Thanks for all the questions. It was really interactive. I expect you all in the session next week. Probably we'll be starting up next Saturday, if everything goes well. So see you there. Thank you.
Thank you, Azad.
Yeah.
Thank you all. Thank you, Ajay. Thanks.
Thank you.